Okay, 2, if I were taking an exam and I saw 2, I'd probably skip 2 and come back to it later. And the reason that, it's a little concerning to me that I'd have to get sort of like an area problem for this and have to visualize that. But let me just point out what I mean by this. If I'm asked to visualize R equals cosine 3 theta, and again, most people don't have much experience with polar equations, but I'm going to just talk about, maybe like drawing a picture of it. I'm not saying it's the most accurate picture, but I'd start theta somewhere, and I want to point out, I really want to stick between 0 and 2 pi. I'm going to stick between that. Now, what do I know? And I'm going to be plotting out, the theta and the r. And it's not easy for me, I'll be honest with you. So if I start at 0, the cosine of 0 is 1. So I'm over here. Again, the angle is 0, but the radius is 1. I got this. And then I wonder, it's going to, sweep through positive numbers. But as soon as I hit, pi over 2, it's going to be 0. So when does 3 theta equal pi over 2? That's pi over 6. So I'm going to say this thing does something like this over here. And it's going to hit that at pi over 6. Now, by the way, if you keep going on, you start to realize it gets negative, blah, blah, blah. But I'm starting to realize that this would be half of a leaf. Right, now again, I don't want to keep drawing it out, but it does keep going on. Maybe something like this over here. All right, something like this over here. Again, it's not the most accurate graph, but I got half a leaf. Right, there's 3 leaves to this over here. I got half the leaf. So what I want to do is just say that I don't want to spend much on graphing, but I do realize this is going to be 1/2 of a leaf. So I'm going to put down, I need 2 of those leaves. Where does the leaf start? Well, it starts at 0, right? Remember we talked about it. And then, of course, over here, that occurred at pi over 6. And then I want to point out, we're really using a formula you learned in Math 120. It's 1/2 theta r squared, all right? So I'll write this over here. It's going to be 1/2. Well, the theta, I'm going to solve d theta now. We're taking little tiny slivers over here, like this over here. That's what we're doing, that arc there. And the r squared is going to be cosine squared 3 theta, all right? And that's going to be area of one of the leaves, by the way. Again, I'm doing half of it, but I'm doubling up, get the full leaf over there. So what do you have to do? You have to integrate 0 to pi over 6, and that's going to be cosine squared 3 theta d theta, all right? Now, before I talk about how to integrate that, I would say if they want an approximate answer, they're letting me use a calculator for this one over here. So you could actually just plug this in a calculator. I will post a Sage video later, but and I'll put in the notes, by the way, where you'll see me doing this in Sage. But I want to claim that, you don't really need to use Sage to do this. You could actually compute the exact problem, all right? So what I want to do is I want to go through that with you. And I want to say, if I were doing this thing and it were an exam at most schools, they would not allow you to use a calculator. They want you to get the exact value for this. So I'd use U substitution. Let me write this over here. So U equals 3 theta, and du equals 3 d theta. That's not so bad. Let me just, pop that in there. Now, if theta is 0, 3 times theta, which is 0, would be 0, and 3 times pi over 6 is pi over 2. And it's going to be cosine squared, u. And what's d theta? D theta is 1/3 of a du. All right. I'm going to get my eraser out. I'm going to kind of erase things I don't need anymore. I don't need this anymore. I don't need this. I did that. Kind of understood this. I did this over here. This is kind of gone. When I say it's sort of like from my memory, it's gone at this point. I'm really struggling with this integration over here. So what I do remember that there's, to reduce the power of the cosine, I have another formula I could use. Let me write this one down for you. That the cosine of 2 theta is actually the same thing as 2 cosine squared of theta minus 1. So the cosine of 2 theta plus 1 over 2 is the same thing as cosine squared theta. And that accomplishes a lot for me. It accomplishes that I can get a square into a linear problem. So I'll write this over here. By the way, I think I made a mistake over here. I put a half, it's a third. I just remembered that. If you remember, I did that substitution. It was 1/3 of a du, the same thing as d theta. So what am I doing over here? Well, I got to plug in now, right? So it's 1/3. And we got 0 to pi over 2. And then we have cosine squared, which same thing as cosine of 2 theta plus 1 over 2. I'm going to bring that on the outside, so it's a sixth now. And then d theta. I can actually integrate this now. So 1/6. The cosine of 2 theta is going to be sine of 2 theta over 2 plus theta. And the limits of integration here are going to be 0 to pi over 2. All right? Let me keep plowing through this. And what do you get? Well, it's going to be sine. 2 times pi over 2 is pi. Over 2 plus pi over 2 minus 1/6. Let's see, 0. Well, sine is 0. I'll put this over here. Because 2 times 0 is 0 over 2 plus 0. Whoops. That's a 0. Let me get my eraser out. It's an evaluation problem now. I get 1/6. The sine of pi is 0. I get pi over 2. And the other term just disappears, all zeros. What do you get here? Pi over 12. That's the exact answer. All right? So I want to point out the exact answer is listed for me. It's right over here. All right? All the work is down over there. But again, I want to warn you against what I just did. If this was a multiple choice exam and they're asking for an approximate, you see that right over here. What I would have done, if they were asking that, that means I can use a calculator. Let me erase all this business over here. I know the correct answer, by the way. It's pi over 12. I would not have done that, though. I would not have gone through that work. But I could do it. Right? That's the point of it. I could do that. What I'm going to do, if I were doing that over there, is I would definitely write the integral down, this guy over here, and then I would use my calculator to do that. And again, I'll do this in Sage, by the way, and not right now, but I'll post a video later for that. And by the way, you're welcome to use any software you want. But I will go to Sage, and Sage, I'm hoping when I do it, Sage is able to do it, and it gives me pi over 12, and I'll also show in Sage how to approximate that. And by that, I mean using a decimal number for that. And that's a good approximate. Now, of course, if it's multiple choice exam, I'm looking at this number I got, which is 0.26. I look in this over here, and I always get dizzy looking at these things, but clearly it's this answer right over here. And we're done. Thank you.